We're moving on to chapter 3, and the first section in chapter 3 talks about exponential functions. Okay, so what is an exponential function? Well, there's these certain functions in algebra that are called transcendental functions, which basically means they transcend or are outside of algebraic bounds. So they have different concepts and different things that we don't normally see in algebra problems. They're not linear, they're not quadratic, they're somewhere in between, right? And so that our easiest example are something called exponential functions. And exponential functions can look kind of like this, right? We can have them look like f of x equals 4 to the x power, or g of x is equal to x to the negative 3 power, or something like that, where we can figure that out. They also can be um, something that's like a portion of a fraction, right, or something like that. So we're going to look at a bunch of different examples, and we're going to get really used to using exponential functions, right? So let's just jump into a problem, okay? So the first one, it says to sketch and analyze a graph of each function, describe its domain, range, intercepts, asymptotes, and end behavior where it's increasing or decreasing. So again, the same common few questions that we ask all the time, right? Okay, so let's take a look at this one right here. And it actually says that we want to evaluate the function for -2 or -4, -2, -1, 0, 2, 4, and 6. And we're looking at the function f of x equals 3 to the x. So how do I make this table right here? Well, there's a couple different ways you can make a table. One way is to just make one and plot a bunch of different points for x. And so you do like 3 to the -4 power, 3 to the -2 power, 3 to the -1 power, and so on and so forth, right? Anything to the 0 power, remember, is 1, so that kind of helps us out. We always know that anything to the 0 power is going to be 1, and so that's going to go crosses right there, right? And so we graph this, and we end up seeing it looks something kind of like this guy, right? It ends up looking, so it starts real low and stays really close to the x-axis, and then jumps up real fast, right? And that's because exponential functions increase super fast, right? It's actually exponential function gives us the term something growing exponentially, right? Going up really quick. So anyway, so if I look at this one, I can answer a couple different questions. So first off, domain, okay? So I'm looking at the x values. So what are the x values in this function? Well, if I look at my graph, or if I look at my table, I notice that I can put any value of x in, and no matter what I get, I'll either get something super, super small, close to the x-axis, or something super, super big, far away from the x-axis. But notice it doesn't matter what I put in for x. So my domain is actually negative infinity to positive infinity, right? I can get something that goes real low to real high based upon what I put in for x, okay? Next, we're looking at the range, right? Range. Now, if I look at my graph, I notice that I get super close to the x-axis, really, really close, really small, but I never go below it, which means it's going to be greater than 0, right? So the way we write this is, remember, it doesn't include 0, but you'll notice because it goes up exponentially, goes really high, I can go all the way up to positive infinity, okay? Now, let's talk about the x-intercept, or excuse me, the y-intercept. Okay, the y-intercept, we notice, when x is 0, y is 1. So the y-intercept is the point 0, 1, right? And it will be for most of them unless it's shifted, translated, something like that. But most of the time, our y-intercept is going to be 0, 1. There's no x-intercept, it doesn't touch, right? And that actually helps us answer the next one. So the x-asymptote is going to be the asymptote is the x-axis. That's what I meant. Okay, so the asymptote is the x-axis. Okay, never going to go below the x-axis again unless it's translated. Then we also have end behavior. Okay, so we can say our limits, right? So limit as x approaches negative infinity of f of x. Well, as it approaches negative infinity, it's going to get super, super small. So as it keeps going negative, it's going to get closer and closer to 0, right? And the limit as x approaches positive infinity, right, of f of x, it's going to continue to go up. Think about it. Already at 6, it's at 729. So it's going to continue to go up really, really high. So my limit as x approaches positive infinity is actually going to be infinity. It's kind of a cool deal where, higher it goes to infinity. closer it goes down, it goes to 0. Okay? And then increasing or decreasing. This one is always increasing, right? And I'm not even going to write that, but you'll see if you think of it as your little roller coaster guy, he's going up the whole time. Now, let's look at another example. We're going to look at g of x now. Okay, so I graphed this one, and you'll notice that this is 2 to the negative x. So the thing that we notice, I see, and I wonder about is that I now have negative exponent, right? So as I put in negatives, remember, negative 6 would be positive 6. It's going to start high and go low. Okay, so let's look at, again, the domain. Domain doesn't change. I can put in any value of x. I can do really big numbers. I can do really small numbers. Doesn't matter. So my domain stays the same. My range, again, also stays the same. I still get super close to the x-axis, but never go below it, and I can go really, really high. So it goes from 0 to infinity. Then the next thing I'm going to look at is my y-intercept. Again, when x is 0, what is y? It's going to still be 1, right? So the x-intercept is the point 0, 1. Okay. Now we can look at our asymptotes. Same sort of deal. It gets really, really close to the x-axis, but doesn't cross it. So then our asymptote is the x-axis again. We can also, again, look at our limits. Now this is where it's going to be a little bit different. Okay. So as x approaches negative infinity, okay, so if we look on our graph, as I'm going this way, my graph continues to go up. So it's actually the opposite. As x goes to negative infinity, g of x is going to go to positive infinity. And the limit as x approaches infinity, we notice that our graph continues to get closer and closer to the x-axis. So it's going to approach 0. And then this one, instead of increasing the whole time, it's like we're going down the roller coaster the whole time. So it's going to be 0. Okay? All right. Super interesting stuff about exponential functions. So here's a couple examples that you could try. We have x to the negative, or excuse me, 6 to the negative x, 5 to the positive x, and then we have a fraction one. So I'm actually going to look at that one right now. So let's start by making a table of values. That's something that we had done for us already, but we're not going to do that. Now, when picking values, it's very similar to when graphing quadratics, right? We pick a number that's kind of around 0 because a lot of things change around 0. So that's what we're going to do. We're going to put 0 in the middle, and then I'm going to do -1 and -2, do +1 and +2. And so now I can put those values in for x. There's lots of different ways to do it, lots of different ways you could get your solution. You could go to a calculator. In fact, that's what I'm going to do, is I'm going to use a calculator to figure mine out. So I do 1/4 to the power of -2, and then I add 1, and that's going to be 17. Okay? Let's go to the next one. 1/4 to the -1 power plus 1 is going to be 5. 1/4 to the 0 power is going to be 1, right? 1, and then add 1 to it, and that's going to be 2. 1/4 to the 1 power is 1 plus 1 is 1.25. That's interesting. That's different. And then the next one, 1/4 to the 2 power plus 1/4 to the 2 power plus 1 is 1.0625. So I wonder if I keep getting bigger for x, what happens? Let's just, for fun, let's add one more in there and let's try it. So 1/4 to the 3rd power plus 1 is 1.015625. So you'll notice that it's getting closer and closer to the value 1 and no longer 0. Okay? So let's start graphing this and let's look. Okay, so -217 is going to be like way up high. -1.5 is going to be right there. 0, 2, 1, and 1.25. 2 and 1.0625. Okay, so you'll see as I graph, kind of starts to sit on the x = 1 line. And so then we know that that's going to be our asymptote. So we can answer the same questions. Domain is still going to be the same, right? Domain will still be any real value, right? Negative infinity to positive infinity. Range now does change because no longer is it to 0, but it gets close to 1. So my range is actually 1 to infinity. So where do you think the 1 comes from? Now I'll let you think about that. Then we have our asymptote. Okay, our asymptote is y equals 1. Y equals 1. So that's this line if you're thinking about it. Okay, that's y equals 1. We also can say that our y-intercept is no longer 0, 1. This one is 0, 2. I'll write that a little nicer for you. 0, 2. Okay. We can also do our limits. As x approaches negative infinity, it's going to go to positive infinity, and as x goes to negative or positive infinity, it's going to go towards 1, right? Write that limit. X goes to negative infinity of, I guess that's h of x. That's going to be infinity, right? As it continues to get small, it continues to go up. And then the limit as x approaches positive infinity of h of x, that's going to equal 1 because it gets super, super close to 1 but never crosses, right? And then this one is decreasing the whole time. So it's interesting that the x is positive, but I'm decreasing the whole time, whereas where I have a fraction as my base versus having a positive number or a whole number having a negative x. Something to kind of think about, okay?